Attendance is on, guys. Okay, so I think we can start. Uh, so yeah, I know, I understand that most of you may not have seen the lectures. So what I'll do is I'll just give a very brief overview of what those lectures are. If some questions come up to your mind, you can certainly ask. But as we all know, you can certainly ask me about these things later whenever you study for the NSEM exams. You can ask me about these questions, these concepts later as well. But still, I'll just zip through the presentation, and in case you have, if something comes to your mind, you can certainly stop me and ask. Okay, so let's just have a look at what content do we have. So this week was this week 8 is about uh, okay, this is not networking. Let me start with the state diagrams first. Uh, mm, 8.1. What exactly is happening? Just a minute, guys. I think I had multiple presentations open. Yeah, that is the case. Okay. Yeah. Okay. So I'll just zip through what this state diagram thing is, and if you have any questions, you can certainly ask me. So we had discussed this structural versus behavioral things, right? That structural aspect of a system talks to you about how the system actually looks like, whereas the behavioral aspect is about how the system behaves. So I gave you an example also that your body, right? You could be thin, you could be fat, you could be tall, you could be short. Whatever it is, whatever way you describe yourself, you could be just perfect, whatever way you describe yourself. Basically the structure of the body doesn't really change that easily, right? It takes up a lot of time and a lot of effort to change the structure, whereas behavior, it can change maybe 10 times within an hour, because that is how we all are. So the same thing is there is a structural aspect of your system, the project that you are currently building, for example, and there is a behavioral aspect. So the class diagrams actually showed the structural aspect about your system. It showed how exactly your system is designed, right? The classes in your system. And there are many ways to show the behavior also. You want to depict how exactly is your system going to behave when it actually starts executing. So a state diagram is in some ways contributing in that direction, that you're going to show the behavior. It's just that the state diagram is applicable to a particular type of state, of a particular type of object. So you have the overall idea is that there is an object out there of some particular class. What really happens, there is a state associated with this object, and the state is nothing more than just the values of the different fields, right? Different values, different fields might have different values. For example, if you have an object of class student, and let us say its fields are, let us say, name, marks, attendance percentage, so on and so forth. So as soon as I change any of these fields, right, I change the name of the student, or I change the attendance percentage, I actually say that I have changed the state of this object. Okay, so as long as the fields of the objects have the same values, I say that the state of the object has not changed. But when I change even even one value within this particular object's realm, I say that its state has changed. And you also have to understand that some of these state changes may be valid, some of them may be invalid. Invalid as in, for example, if you are talking about a banking transaction, and let us say there is some object which is trying to represent that banking transaction. That whenever a debit happens, the old transaction value, the old amount in your account has to match against it, right? So it's like old amount plus transaction amount should be the new amount, right? If there is anything else, then there is a problem, right? Even though in C++ it is possible, let us say, to have three different values which are independent of each other for these three different fields, but the domain in which you are operating, let us say the banking domain, it will enforce certain rules on what could be what is a valid state and what is an invalid state. So from that perspective, not all the state changes for an object are actually valid. But yeah, there might still be a number of states which are valid, and your object can transition from one state to another. So the transitions, okay, this transition of changing the values from one state to another state, they are known as transitions. And the events on which such a change actually takes place are known as events, right? So there are two aspects that you can see in a state diagram. There are two states, and then there is an arrow between these two states, means that there is a possibility of a transition from this state to this state. And When will this transition happen? You write the reason for it, okay, the actual case when this transition happens, and you call it the event. The event here will make sure that this state goes from this state turns into this state. And remember, we are talking about the same object, okay, they are states of the same object. We are not talking about states of something else. So basically, whenever I say something like this, it essentially means that the overall values in the object, there is some change from here to here. And sometimes you might want to say that even if a particular event occurs, I would only the object will only change the state when certain conditions are also met, right? The example, if you go back in the banking domain, the debit in an account can only occur if it has that much amount of money, right? If you try to withdraw more money than what you have in your account, that kind of a transaction will be declined, right? So even though the state should have changed on receiving a debit request, um, the state does not change because of certain conditions. So that is the same thing here, that if you want to show that the state will there will be a transition between these two states, but it is conditional based on certain condition. So then you can also put something known as a guard condition. You just put it beside the name of the event in square brackets, and that becomes the guard condition. And last, another thing that you might want to put in your state diagram is just a description of what really does this state transition mean in the real world. So in that case, you can put a simple slash and write whatever description you want. So overall, this is how your state transitions will look like. There is an event which occurred because of which this state became this state, and there might be a condition that this transition will only take place when this condition is true, and here you are just explaining what effect this transition is going to have on your system. There are two more things that we often might require, and these are the initial and final states, because whenever you create an object, there will be some initial state, right, in which it goes. So that happens when the constructor is called, for example. And similarly, when there is some final modification to this object, after which this object is not going to be used, could be considered as its final stage. And right after the final state, it goes for destruction. So there are two symbols there in state diagram which can be used to show this, that basically this is the starting state of this object and this is the ending state of this object. And you can, just to show transitions, if you can basically write something like constructor called or whatever it is, right? And then the first state of the object appears. So this is overall the idea of a state diagram. State diagrams are supposed to be used for certain objects, okay. First of all, there might be far too many objects in your system, and you may not want to show a state diagram for all. So in that case, you will have to pick what are the important objects in your system. And then even these states, there could be far too many states to talk about in a state diagram. So you might only want to show certain states which are indicative of important events in the system. So this is in your hand. When you use a state diagram, you'll have to make two decisions: what objects do I make a diagram for, and then what are the events associated with that object for which I will show these transitions. Any questions? If there are any, I can answer them. But this is overall the brief overview of state diagrams, that if you want to show the what exactly is it going to show, it is going to show the changes that occur in a particular object when the system is executing. If you want to show such a kind of a scenario, remember that all these design diagrams, their purpose is to communicate. Okay, the idea is that you want to communicate the design of your system to someone else. And in order to do that, you can use multiple UML diagrams. So one of these diagrams, that is the state diagram, it only talks about individual objects, how individual objects modify themselves, or they are modified via events in the system. Okay, any questions on this? So you can certainly drop me your questions later as well. So let me move over to the other part of this week. The other part of this week is about a system building skill, and I told you, right, that I'm gonna force you to learn some system building skills in this course. uh, it's just that I understand that it might be too hard for you to actually try these things out, so that I'm just teaching it to you. It's not going to be a part of your end semester exam, but it will be nice if you learn these things, because as I said, these are skills that you will have to acquire across multiple subjects, that too uh, with your own efforts. Okay, nobody is going to teach you all these things, so it will be nice if you if you can learn these things in this course, at least start with these skills, and then maybe later when when you study these skills in detail in different courses, maybe it will be easier for you, because you might already know some terminology beforehand. So the system building skill for VK is networking. And if I just want to give you a basic overview of what networking is, let us take the example of opening up a web page in the browser, right? So what exactly happens? You type, let us say, something like www.iitl.ac.in, and then you press enter, and then what really happens? The page loads. Okay, and I don't think there will be anyone currently in this meeting or in your batch who has not done something like this, right? I mean, I'm pretty sure everyone has done something like that. So but what really happens in the background, maybe you do not know about that, right? So a lot of networking goes along in the background. So for example, let us say you just want to know, you just want to open up the page of www.iitl.ac.in slash whatever it is. Just want to open this page. The issue is computers and networks and computers in general, they don't really know what this particular string means, right? I mean, we've seen this during the first few lectures of ITP, that computers really are not that well accustomed with strings, right? They are basically they work on zeros and ones, right? And the same thing is this here as well, that your networks really don't know about these strings straight away, right? These are for your convenience, so that you don't have to remember numbers. So what really happens is that there is a conversion. There has to be some kind of conversion between the strings that you type and the numbers that they represent. Okay, so the two most common numbers which are used on computer networks are IP addresses and port numbers. Now I know IP addresses are something that you guys are already aware of. You would have heard the term IP address many a times. They are basically unique numbers. They are unique identifiers for a member within a network. Okay, so now I'm trying to make it slightly more technical. So I'm saying that there is a network. A network essentially means that there are multiple computers, there are multiple devices. Earlier they used to be computers only, but now we have smart devices as well. So essentially there are multiple devices which are somehow connected with each other. Somehow, we are not talking about how, that you will study in your computer networks course, but they are somehow connected to each other. Okay, either physically or via these is either via physical mediums like wires, or wireless mediums like whatever, right? Your 4G connection or something like that. But the idea is that a network is basically a collection of such devices which are connected to each other. um, this network could be owned privately. Let us say IIITL's network. We call it an intranet, or it could be the worldwide network on which we are currently talking, and this is known as the internet. Port numbers are essentially, you basically identify a device on a network with the help of its IP address, and a port number is more like a communication channel. It defines that there are two members on the network and they want to communicate with each other. A port number is like a particular communication window. Imagine going to a railway station where there are so many reservation counters. So you can say that a railway station is the IP address. There are so many railway stations. How do you they are all connected probably with each other, right? I mean, I'm assuming that all railway stations in India are probably connected with each other via the railway system that we have. And in these reservation counters, you can probably consider as some kind of ports, that if you want to get onto these trains, you'll have to go into one of these windows and get a ticket booked. Okay, so the port numbers are basically numbers that define specific communication channels between any two members of the network. So here there are no IP addresses, there are no port numbers. There's just a string, right? flightl.ac.in. And if you want to know these numbers, the first thing that you can probably do is issue a ping command. You can say ping and then the name of that particular domain which you just typed on the web page, and then something like this will appear on the screen. I'm talking, by the way, all these commands are associated with Linux only. So if you just do ping and then the name of some domain, this is something, so this is what appears on your screen. And here this part really is basically the IP address. The IP address looks like this. There are four integers separated by dots. It's not really a valid way to tell you what an IP address is. It actually means something else. These integers have certain restrictions, right? They cannot be just any vague integers. But yeah, this is precise for now. It is sufficient to know that they are basically four small integers separated by dots. And the ping command is not really the right command to check out the IP address. It's just one way in which you can do that. But the another proper command to know more about network details is the dig command. And you can use dig command with any domain like google.com or IIITL.ac.in, and it shows you much more information, right? So this is what it shows you if you try to dig the IIITL.ac.in domain. Okay. Basically there is an answer section which talks about the IP address of IIITL.ac.in, which is here. And there are some more entries. For example, there is a CNAME entry which essentially says that um, this IIITL.ac.in is a alias for www.IIITL.ac.in. So you can just type this instead of this. That is what it is trying to tell you. And let us say, so this was the IP address of the IIITL system from where your page was served. But because it's a network, both communicating entities have an IP address. So if you want to know your IP address, you can use the command IP space A. Okay, this is what it turns out to be. It will give you a lot of information, but your own IP address appears somewhere here. And port numbers, we did not talk about any port numbers, because when it comes to talking to when it comes to discussing when it comes to loading pages over internet, these port numbers are actually fixed. Okay, if you are using a website that uses HTTPS, the port number is 443. And otherwise, if you are using HTTP, the port number is 80. And by the way, these port numbers are well known port numbers, and these are assigned to specific protocols, so you don't have to mention them explicitly. The system knows them implicitly. That is the idea, right? And there, if you want to, by the way, on your port, on your system, on your side of the communication, there will be many more ports opened, usually for communicating with the same domain. And if you want to know more about that, you can use the netstat command. Okay, and here I'm just using the netstat command, and then I'm doing a grep so that only those connections turn up which are for IIITL, and this is one way to look at it as well. So the whatever processing we have just seen, this processing is basically a very complicated set of routines, and you can see already that so much goes on in the background. There are so many translations, and then this is much before the actual transmission takes place, right? I mean, this is just the translation that I have just showed you, that in order to actually figure out where you want to communicate, this much amount of thing has to be done. The string has to be converted into an IP address. You have to know what port it is that you are trying to communicate with. So this much is happening just for translation of a string to numbers. the actual network communication is even more complicated. Okay, and there is something known as the OSI reference model. Okay, so there is a reference model. You study about it in greater detail in your networks course, but the idea is that if you try to do so much of processing at one particular place, it is going to make it a very difficult program or application to debug, right? And plus there can be so many issues as well. So the OSI reference model says that we should divide all this processing into multiple layers, okay, and each layer should be given a specific task, and that layer should only perform that task and then pass it on to the next layer, and that is where we can divide the processing into separate modules, and each module will have its own responsibility. And the OSI reference model is basically a conceptual model. It is not necessary that the processing is divided exactly in these seven. So there are seven layers, by the way, in OSI reference model. So it is it's basically a way to tell you that this is a good way to build your networking applications. It doesn't really mean that you have to follow everything as is, right? And many a times it is not really followed as is. Okay, the idea is that you need to divide your complete networking process into multiple layers. That is the only thing that it talks about. And there are the idea of these layers is that at different levels you add or remove certain information from the packet, the data that you want to send over the network. What really happens is that these layers keep on adding some metadata over it, right? Some additional data over your actual data packet. And then on the other side, when once it gets received on that machine or that device where the data was supposed to be sent, this information is taken away, and then what is left is only the data that you sent, right? So this is what really happens. You don't have to remember these layer names. You'll study all this when you actually study networks. But this is the idea, that here is the sender, here is the receiver. You say that I want to send this data to this receiver. From here onwards, okay, things start moving down. Okay, so this application layer is basically some application that you use. It could be, for example, Facebook, and you're chatting with your friend over Messenger or something like that. So this is the layer where you said I want to send this string to my friend, and then from here onwards, each layer keeps on adding more stuff over the data that you asked it to be passed. And sometimes the data might be too huge to go in one go, so then it has to be broken down into multiple chunks, and then each chunk actually is treated as a separate data item. And then each layer keeps on adding some more data to the data that you provided. Then finally this last layer is basically the communication channel. So in your case, it could be your Wi-Fi, it could be the 4G network that you're using, it could be an actual wire which is transmitting data from your machine if you have a Ethernet port or something like that. But this basically, at the end of the day, it the data starts traveling. Okay, it starts traveling over the communication medium, and then it reaches the other machine, the other device, and then the repeat process is performed. Okay, so every layer knows how to take out the data that was meant for it, and it keeps on taking out that piece of data. And by the time data reaches your friend's Facebook Messenger, it is only that data which you wanted to send. And all this happens at lightning speed, so you really never realize that so much of processing is going on, right? And so this is just a way to conceptualize it. At each layer, the data gets bigger and bigger and bigger. Then it gets transmitted over a communication channel. At the other end, because it flow from the flow was from layer 7 to 1, and at the receiver the flow is layer 1 to 7. So at each layer, the layer keeps on taking out the data that was added by its peer, and at level 7 you just have this data left. So this overall process has many layers. You don't really need to know about all the layers. seldom do we actually need to know about all the layers, but there are two very important layers which are used by programmers. Okay, and these programmers are the layer 4 and layer 5. Okay, and these two layers, layer 4 is basically it is basically the transport layer. In fact, uh, it should be layer 4 and layer, yeah, I think it should be layer 4 and yeah, layer 4 and layer 3. Sorry, it's not 5 and 4, it's 4 and 3. So layer 4 is known as the transport layer, and its job is to manage connections as in from sender to receiver. You have to do a lot of things just to make sure that there is a connection maintained between these two machines. So all that responsibility is with transport layer. And not only that, it also makes sure that if the data was divided into chunks, then these chunks reach the sender, the receiver, in exactly the same order as they were sent from the sender. Because network is something that is highly unreliable. Many a times you will send some data, but it gets lost over the physical medium. So it is the responsibility of the transport layer to make sure that everything reaches from sender to receiver. And then the network layer, that is the network layer works one layer below the transport layer. So that network layer knows more about the hops as in how many hops should the network, the data packet has to travel in order to go from the sender to the receiver. So for example, if your friend is also sitting in the same room as you, maybe the number of hops are going to be very few, maybe just one hop, and you reach your friends, and the data reaches your friend's machine. But he or she could be located at a different geographical location, in which case there will be multiple hops. Okay, your data will go from one position to one point to another, then from another to another, then another to another. So all this information, how would the data actually travel along the network, that is known to the network layer, and that is the job of the network layer. So these are the only two layers you need to know about. In fact, probably the only two things that you need to know about are the IP addresses and the port numbers. As long as you know these two things about your communication mechanism, you will be able to establish a connection using some kind of C++, Java code, right? So any queries on this? I know it's not really something that you are supposed to know, but listen to it like a story. Try to see what this story tells you. So this story was about computer networks, that how does data travel from one point to another point. So there are layers which process them. At each layer, you try to add some information, and then at the peer of this layer on the other end knows how to take this information out from the data. So the actual data that you send and the actual data that gets received, that is exactly the same. But while it travels through the network, uh, things get added over it, and then things get removed from it before you know it. Any questions on this? So it's fine. I mean, you can certainly have a look at it later, and if you have any queries, you can send it over to me over email as well. Anyhow, so let me just stop this. So now there's one more thing in week 8, and that is the POSIX sockets. Just a minute. Where are POSIX sockets? Yeah. Okay. So I just told you what these networks look like, and I told you that it is possible for you to be able to create a connection between any two machines on a network, as long as you know the IP address and the port for communication. If you know these two things, you should be able to talk to another machine on the same network, not the same network as in actual same network. That is a incorrect terminology in terms of networks. But yeah, what I mean is that in terms of that the two machines are somehow connected with each other. That is what I meant. So if you want to do that on your own using, let us say, C or C++, there is a library out there called the POSIX sockets library. So this library can be used by you. So let us just have a look at what sockets are. So a socket is essentially an end of that logical communication session that I talked about, right? So I told you that there are two members on, actually this is layer 4. So there are two members on a particular network. So then what you really do is that you want to you have the local IP address, the remote IP address, the local port number, and the remote port number. These are the four pieces of information you need to know, and then you can establish a connection between these two. In fact, the connection is already established, I would call it, right? And this connection is known as a pair of, so the two ends of this communication channel are known as sockets. So what exactly is a socket? It consists of these four pieces of information, and there are so sockets appear in pair, by the way, right? So you have a socket at one end, and then you have a corresponding socket at the other end of the communication. Okay, and if these two sockets are connected to each other, you can then start sending and receiving data between these two sockets. So the only thing I want you guys to probably take away from this particular this particular set of lectures is to understand how the actual networking works. Okay, the scene of the network. How do you do network programming? So in order to do that, the first thing you have to understand is that there will be two programs that you will have to write. Okay, till now whatever code I showed you, they were basically single executables, right? So but today when I'll show you the example, I'll have to show you at least two. Why? Because there are two communicating entities, and so there has to be two processes. These processes ideally run on different machines, but to show you the example, I'll just run it on the same machine. Okay, so but you do need two different processes. One of these processes will play the role of a server. This server does not mean the server machines. Okay, the machines that are there in data centers, those huge machines, they are not that kind of servers. They are basically a server process. Okay, and then there is another process called the client process. The difference between the server process and the client process is that the server is supposed to be on or all the time, right? So let us say when I wanted to start this lecture, I went to the domain of WebEx, okay, their website, and their site was up. If the site was not up, I would not have been able to start this meeting. But as soon as our meeting ends, we'll all leave the WebEx website, and we'll do something better with our lives, instead of being on WebEx. But yeah, the idea is that WebEx has to be online all the time. They don't know when will you want to conduct a meeting. So the WebEx process, there will be some process, right, which is facilitating everything that is happening here. So this process is the server process, and the server process has to be on all the time. All the time, as in whenever a client wants to connect, the server must be there. So that is the only difference. The client, on the other hand, could be free. Okay, the client comes online, connects to the server, does whatever is required, and then goes away. Okay, so there are no compulsions on the client process to be on all the time, but there is a kind of compulsion on the server process to be on all the time. So that is the only difference between server and the client. But once the communication setup has been made, then it doesn't matter, right? It doesn't matter who is the client and who is the server. Both can send and receive data. Okay, so but one thing that you have to take, one takeaway from this is that if you have two processes, one is the server, one is the client, the server must be running before the client starts. That is the only thing you need to remember. And in a typical networking flow, this is what really happens. There is a process which we start, and it starts listening for connections on a fixed port number. Okay, and this is the server process. The server process starts running on your server machine, and it says that okay, from here onwards, if any connection comes, if a connection request comes up on this particular port number, let us call it P, I am going to be the one who is going to respond to it. And then once the server process is already running, you know that the server process is already running. On the client, you need to know the IP address of the server, and then the same fixed port number. On the client side, you need to know both IP address as well as port number. On the server, the IP address is implicit. Implicit as in it is, you're starting the process on the machine. You don't have to tell what is the IP address of the machine. The system knows how to figure it out. So from the client, once the server is running, you make a request to connect to the server, and then there is some all those things happen in the background, which I talked about. Data flows from the sender to receiver. At the receiver end, all those things are taken out. So once all this has been done, what really happens is a connection is established between the server and the client, and this connection has two ends. Okay, there is a socket at the server end and there is a socket at the client end, and from here onwards, these two sockets can send or receive messages from each other. So the only aspect of the server here is the server is the entity which receives the connection, the client is the entity which requests the connection. But once the connection gets created, from there onwards you really don't need to do anything. Everything works. So keep in mind that this part has to be started first, and only then will this part come in. And that at this stage, now server and client, there is no distinction between them. They can both share data with each other. So there is a POSIX library. There is one for multi-threading. So similarly, there is one for sockets. And but the problem is the good thing about this socket library is that it will give you a socket descriptor, which is very similar to a file descriptor in C. So these read and write methods that you used over file, they are also they are also applicable to this socket descriptor with some conditions, of course. But it makes it much easier. So essentially, even a socket descriptor is nothing more than a file. That is what it is, right? A socket is also a file. So the POSIX library allows you to do this input output over sockets in pretty much the same fashion. But this library, unlike the threading library, has so many things to do, right? I mean, networking is much more harder as compared to multi-threading. So there are so many header files, there are so many structures that you need to know about before you can start working. So it will be very challenging for you at this point of time to do that. So I've just created two classes for you. These two classes can be used in order to communicate between server and the client. So I have two classes. I'll just show you what those classes are. But just to give you a brief overview, this is the overall idea. At the server end, you create a socket, you bind it to a particular port number, so that this port number now is going to be handled by this particular process. And then you start listening. You basically tell the system that this socket is going to be a listening socket, which is going to accept incoming connections. And then you go into a blocked mode, as in, you say, I am now going to wait till a new connection is requested. This is happening at the server end. Once a new connection gets accepted, there are two methods, send and receive. You can use it to actually send and receive data from the other end, from the client. And then at the end, you just close this socket. At the client end, you just need to create the socket and then make a request of connection to the server. If the server accepts the request, you can then use the send and receive methods, and then use the close method to close it towards the end of the communication. I have created two utility classes for you, socket and server socket. Socket is basically representing the client end of the communication, and server socket is representing the server end of the communication. And once this connection takes place, there are methods within your classes, the server and server socket classes, called send message and receive message, which you can use in order to send and receive messages. I'll just I have 10 minutes or so. So I'll also like give you an idea of how the code looks like. So here, this is the class. By the way, I am using, now you can see where exception handling could be very useful, because what I have done here is I have used this, by the way, you can see my VM, right?
Yes, sir.
Okay. So here you can see that I am using a socket exception class, and it is actually extending the C++ exception class. So this is a standard class provided in C++ library, which is supposed to be used for exception handling. So I'm just creating a new type here. Why am I doing this? So that I can do something like this. Um, whatever network operations I'm doing, I'm putting it inside a try block, and then wherever there is a problem, I just throw a socket exception type object, and then it gets caught here. I'm not using try and catch anywhere in these two classes. Okay, socket class as well as server socket class. I am not using um, any exception handling here. What I'm doing is something like this. Wherever there is a problem, I simply do a throw. Okay, and then where does it gets caught there, right there, the try and catch that we have put in the main. So this is the advantage of exception handling. Wherever there is a problem, I simply do a throw. You can see so many throws here, right? Because there are so many ways in which networking can go wrong. So at each step, there are so many throw statements, and I just need to catch them at one place. So this is a good example of why exception handling is an important aspect of system building, right? It allows you to write clean code. Otherwise, I will have to stuff every place with let us say see out statements, and then I probably I won't even realize which see out statement is the actual output statement and which see out statement is an error statement, so on and so forth. So the complete code for exception handling is written at one place. Anyhow, so this class has some methods to connect to the server and then send a message and then receive a message, and it basically hides all these sockets. You can see, the kind of header files I have to use here. There are some 2 or 3 header files that I have to use, and then I have to create sockets, I have to bind them to addresses, so on and so forth. So all these things are done uh, in these two utility classes. You can use it to in your projects also. If you want, you can use them in your projects as well. They are very basic. The only thing that they can do for you is send some string messages from the server to the client and the client to the server. But what I wanted to show you, what you should understand, is that whenever you are writing um, networking code, the server has to be started first. There will be at least two applications, by the way, the server and the client. So here I'm going to show you these two applications. Let us say here I'm going to run the server application, and you can see what is happening here, right? It is just going into a kind of wait mode. Okay, so what really is happening? I have created a port and I have done everything, all those things I've done, and now it is waiting for a connection. It is waiting for a client to connect to it. Okay, so now here I will start the client program. And as soon as I started the client, you could see that this program also completed. Why? Because uh, the connection request came from the client. It connected to the server. Then there was some message exchange. The client said hi from client, and then the server replied back by saying hello from the server. So this you can do that. There are two programs here: the server test and client test. So in the server test, you can see that I am just providing a port number for the server socket to be created. And then I say, please listen for a connection. So here my code will actually get blocked. Okay. whenever I'll try to listen for a connection, the program gets blocked here, and then here what am I doing is I'm giving the IP address of the server. This 127.0.0.1 means local host, so basically this is a loop back IP address that it basically points to the same machine from where you are trying to connect. So this is like connecting to the same machine but via the whole networking stack. Okay, via all those layers, those net those 7 layers that I talked about. And then the other thing I need to tell is the port number at which this server is currently running. And then I make a call, I make a request to connect to the server. If this particular call succeeds, from here onwards it means that the sockets are there now in place. It can send a message, and then it can also receive a message. The same thing is here. As soon as the connection comes in, this method call returns, and from here onwards messages can be received or sent. I know this was a very hectic lecture, but any questions from your side? You don't have to know all the things that we discussed today, but at least take out one takeaway from the networking part, that whenever you will do networking, you'll need to have at least two entities. There will be a server entity and there will be a client entity. And the server entity, that process has to start before it should be running. Okay, before the client tries to connect to it. So that is the first takeaway. The second takeaway is, there are sockets, and these sockets are at both ends of this communication channel. And once the sockets are created, from there onwards there is no difference between the server and the client. Both ends of the socket are capable of sending as well as receiving data. So this is not going to be a part of your end semester exam, so I know many of you do not care about it, but please, at least try it out. It's a piece of knowledge that you can gain, and if you can gain this knowledge in the first year itself, it is going to be very helpful for you when you study networking. So any questions from your side? Okay, so the that will be it for today, I guess, right? I mean, the projects, I know some of the emails I have on my email. I have to reply back to them, so I will do that. But please keep working on your projects, and in fact, I'll be quite free in the next week, so I can discuss. If you want to have one-on-one discussions with me, I can even do that in the next week. So but please keep on working on your projects. Okay. Yeah, yes, I'll I'll do that. In fact, that is the next on my list. Once I'm done with all the lecture content, the next thing I'll do is to prepare the lab solutions. I know that you guys have been waiting for it. Don't worry, it is there on my list. I have so many things to do. Once I'm done with the lecture content, the next thing I'm going to do is to prepare the lab solutions for you guys. Okay, any other questions, guys? Okay, thank you. Bye.